tearing up the door frame again. Because the other day he tore up the door frame. Okay, anyways, we are starting a new unit today. Tests went okay. They weren't that bad. On the lesser chordates. So we are moving on to the greater chordates, which is amphibians, reptiles, birds, and mammals. We will spend the rest of the semester working on these. Now, with these dissections, we're going to have a final dissection, which is kind of comprehensive. Well, not comprehensive. It'll be a dissection test. So we'll have these animals out and we'll have pins in them. So when you dissect these animals, try to be very careful with the dissections because all the animals you dissect from here on out will be on your final, if that makes sense. So don't tear them apart when you dissect them. Keep them in good shape because the animals that you dissect, we will keep and we will use them again for the dissections, or for your test. When we get back from Thanksgiving, so we have this week, we have 2 days next week, and then when we get back from Thanksgiving, we have 2 full weeks, and then 1 more week after that. But the last week doesn't really count because that is finals week, and that finals week is it doesn't really count because it'll have a weird block scheduling again. So it's not going to be like a normal. So it's just 2 full weeks after Thanksgiving. So that's kind of what it looks like. So we have 3 weeks plus 2 days next week to learn these bigger animals. So we have amphibians, reptiles, birds, and mammals. And we should be able to bring my snake if Fisher approves it. Hopefully we'll be able to bring Zozo. Zozo has been a really good boy lately. The only thing I'm kind of worried about is the car ride with him, but hopefully he will do well in the car and not be too stressed, and he'll be able to come visit if Fisher approves it, of course. So anyways, today we are learning, we've covered quite a bit, and it's really impressive.
That's very much the office.
It's really impressive that we have covered so much in such a short amount of time because we've gone through all of these. We've gone through agnatha, gnathostoma, chondrospes, and osteopes, and now we're to the final 4, and we are going to start with amphibia. So with amphibia, there are 3 main orders: Chordata, Gymnophiona, and Anura. Chordata and Anura are the 2 that most people are most familiar with. Chordata is the salamanders and newts, and Anura are the frogs and the toads. Gymnophiona is the one that most people don't know much about at all. These are the Sicilians. Sicilians are a little bit weird and different. Sicilians are they look like giant worms, but they are actually a type of amphibian that lives in rainforests underground, and they're actually really kind of interesting, but they are considered an amphibian. Salamanders and newts are fairly common. We set up a pitfall trap in the outdoor classroom. We caught a newt last year for wildlife conservation. It was pretty exciting. And then frogs and toads, we have tons of frogs and toads all around this area. Specifically, we have a lot of the little tiny frogs. Blanchard's cricket frogs are a very common one, and western coarse frogs are another common one that we have a lot of around here. some characteristics of amphibians. These are the first group of vertebrates to make it on the land. Now, not the first group of animals, because we had insects that were on land before. So there are other animals that have transitioned onto land, but this is the first group that has backbones, or bones in general really, to make it onto land. There have been like those lungfish that have kind of started to transition onto land, but this is the first group that have made it onto land completely. And they are going through the complete metamorphosis process. They do need to continue to live close to water, so they cannot completely transition away from water because their eggs need water. They have to go back to water to lay their eggs. The young need the water to survive because they have that transitional tadpole stage. And the skin needs to stay moist. This is more of a need for frogs and salamanders and less for toads. Toads can actually live further away from water than frogs and salamanders. They can breathe through their skin. About 50% of their oxygen intake comes through their skin and about 50% through their lungs. And they are considered an indicator species. An indicator species is an animal who is very sensitive to the environment. So if they are present, then that means that the oxygen is healthy. If they are absent, then that usually means there's something wrong with the environment. So frogs and toads and salamanders, they are an indicator that the environment is healthy. So we found a salamander, well, a newt to be more specific, at the outdoor classroom, and the fact that we found a newt is an indicator that the outdoor classroom, or at least the part that we found it in, was probably in good health.
We had like crazy deer. That's what each other like 200 deer.
So this is an ichthyostega. He's kind of cool looking. This is a fossil that was found. They think that this was the kind of transition species that was the one that transitioned onto land. So he was the one that made the transition from water to land. He was the first one that made kind of that first step and came from water and made it onto land. And the reason that they think that this was probably the one is because his legs are still so closely resembling fins and flippers. And he has so many parts that are very similar to a fish. And if you compare his skeleton to the fish skeleton that we just studied, he has so many features that are super similar to a fish. That's what they were going by. So ichthyostega is most likely the one that is closest to the common ancestor that was the first one that came on land. So amphibians have really cool skin, and this really cool skin allows for them to do many cool things. So first of all, it's very slimy, and the sliminess of the skin has several different purposes. First of all, the moisture of it. the moisture helps them to detect, to keep them wet. It keeps them, makes it so that they can breathe better, and it helps with absorbing the oxygen from the environment. It's also a defense mechanism. So one way we used to compare it at the zoo was that if you like to eat jelly beans taste just fine, but if you put slimy like soap on a jelly bean, then a jelly bean tastes really gross. And that's true for animals. Animals don't like to eat things that are slimy as much, so it's a defense mechanism, makes them taste bad. Their skin is also really good for bacterial resistance. There's been a lot of studies done on the microbial resistance of their skin, and we've been able to learn a lot about bacteria resistance from studying frog skin. They do have some really cool pigment cells in their skin that are called chromatophores, and that gives them the unique coloration. So not all frogs are reliant on camouflage. Some of the poison dart frogs have very vibrant colors that they use for defense, like blues and purples and reds and things like that. And so the chromatophores are really bright in those cases. Poison dart frogs have those bright colors because they don't need to camouflage. In those cases, they're trying to stand out for the purpose of saying, hey, you don't want to eat me, I'm bright because I'm dangerous. And so it's the same reason like a bee or a wasp has the black and yellow patterns, or the same reason that a skunk has the black and white patterns. Toads have what's called a parotid gland, and this is the parotid gland that you see right here. That's actually a poison gland that's kind of on their shoulder, like right behind their eye, and that parotid gland produces a poison that makes them taste really bad and toxic to other animals. So this is what frog skin looks like. This is just a drawing, and this is actual microscope of the frog skin. So they have these very large poison glands, and then they also have mucus glands. So here are some examples of the poison glands, and then here are some examples of the mucus glands, and then they have the pigment glands. But the skin itself is actually very, very thin. Frog skin is super delicate. It's very easy to damage. When we worked at the zoo, we had various frogs that we would use in programs, but frogs were one of the animals that we would not allow students to touch just because their skin was so delicate and fragile, and it is very easy to damage their skin. But again, one of the reasons their skin is so thin is to allow that air to go across the surface. The air has to cross because they do about 50% of their breathing through the skin. If it was really thick, they couldn't breathe through it. So thin skin is important for breathing, but it's also easily damaged if it's really thin. They do have a lot of other defenses. The warning color, of course, for some, but they do have camouflage for others. So not all of them are going to have that bright warning coloration. Some of them do have really amazing camouflage. If you've ever picked up a frog or a toad, then you know that you're probably going to get peed on. That's one of their best defense mechanisms, is peeing on stuff. They have a rather large bladder that holds a rather alarming amount of urine in them, and that is one of their best methods of making you drop them, because that's the first thing I usually do when I pick up a frog and get peed on, is I drop it right away. It's a very effective way to make you drop them. So very effective for other animals too. The other thing they're going to do is they're going to puff up their bodies to make them look big. When something comes near them, they will automatically just puff up. In the animal kingdom, looking bigger usually makes you look meaner, and it's a way for them to just kind of protect themselves. Or it also makes them more difficult to eat, especially if it's something like a snake. If a snake is trying to eat a frog or a toad, they're going to puff their bodies up because it just makes them that much more difficult to swallow. So here are a variety of different poison dart frogs showing their different coloration and how they can vary across species. You can have some blue ones, yellow. I know there are purple ones, although I don't see any purple ones up here. But green, orange, red, they come in quite a variety of colors. And again, the only reason for them to be this bright is to say, stay away from me, I'm toxic, I taste bad, you don't want to mess with me. Some of them can be quite severely toxic, and if you touch them, you can get sick from them. The people who live in the rainforest will take their darts, which is why they're called poison dart frogs, and rub their darts on the back of the frogs and get the toxins on their darts so that when they go hunting, and they use their darts to hunt other animals, it will stab the animal and poison the animal when they shoot them. So other things about amphibians, the eggs lack a hard shell and must be laid in water, sometimes in clumps or strings. We have a koi pond that I built in my backyard, and the koi pond attracts usually an American toad every year, or a couple of them, and they lay theirs in long strings. It's really kind of pretty, it's almost like a ribbon. But sometimes it's clumps and sometimes it's in strings, but for the American toad it's always in a string. But it's really pretty when you look at it. They don't have a shell, it's really kind of like jelly-like, and so that's why it needs to be laid in water, because otherwise they would dry out and the egg wouldn't survive. The method that they use for reproduction is called amplexus. Basically, the male will go behind the female and kind of grab them under the arms and hold them still, and the female will release the eggs into the water, and the male will release the sperm into the water, and it's a form of external fertilization. So they don't have any internal fertilization. Now, one of the things we are going to do in class is learn frog calls, and we will have a frog call quiz. So we're going to practice with some frog calls, because there are many frogs, especially here where we are in Missouri, and frog calls are unique to different frogs, just like bird calls are. So you can identify frogs by their call, just like you can go out and listen to birds and identify birds by their call. So we are going to learn some frog calls and see if we can work on identifying them. Oh, excuse me. And have a quiz over the frog calls. So some amphibians take care of their young, and some of them will leave the young behind and like leave the eggs behind. It really just depends on the species. There was a species called the gastric brooding frog, which is now extinct. There is a specialized pouch in the frog's throat, and it would basically swallow the tadpoles, and the tadpoles will develop into little like froglets in the throat pouch, and they would hatch and then turn into tadpoles and then turn into little frogs in the throat. And then this one is still alive. It's called the Suriname toad. Have you guys heard of that one? Yeah, heard of it? Oh, it's so weird. It's one of my favorites. Of course, you guys know by now I like the weird stuff. If you haven't figured that out, then you haven't been paying attention. The Suriname toad is so cool. It's this big, funky looking toad, and the female's back gets really soft when she has eggs, and the eggs get embedded in the soft tissue of her back, and then it's like turned spongy, and then they hatch in her back, and the little tadpoles grow in her back and swim around. It's very cool, like in these little holes in her back. So if you have what's it called, tryptophobia, where you don't like the little holes, it would really freak you out. And of course, I'm gonna show you a picture, because why wouldn't I? Because it's me, and that's what I do. But the Suriname toad is still alive. I can't remember where it's from. But it's probably from Australia. I should look it up. All the weird stuff's from Australia. From Amazon. South America. Slow-moving water sources, rainforest pools, moist sweet litter, Trinidad and Tobago, pretty much the Amazon basin. Whoa, that's a cool picture. Scientific name is Pippa Pippa. It's a fun scientific name too. Pippa Pippa. So this is amplexus. So this would be the male and this would be the female. A metamorphosis. We're going through life stages. And complete metamorphosis again has 4 stages: egg, tadpole, transition stage, adult. And here's a Suriname toad. Isn't that cool? Its head is all squishy and triangular. This is its head. Look at its, there's an eyeball right there. There's a tiny eyeball. And then these are all eggs, but look, that's an actual little frog in its back. See its head? Isn't that neat? They hatch and turn into little frogs in the mother's back. Isn't that the coolest? There's like another little frog there. Maybe that one's already come out. There's a little frog there. But I like this one because you can actually see the little frog head. That's so cool. And he was like, yeah, it's great, isn't it? There's its leg. That's another leg. But its back turns all spongy, and then she's such a good mom. Look at her. She takes care of all her babies on her back. She's such a good mom. Her face just gets me. I mean, look, she's got this point, and then it's got like a tiny eyeball, and then a massive back. It's so funny. Oh, I think they're so cool. All right, so this is the gastric brooding frog. I believe they are extinct now. So they basically swallow the babies down, and the tadpoles like live inside a specialized pouch, and then they come up when they are big enough. So they didn't go extinct not too long ago, because here is a baby in the mouth, and you can see it, the mouth open, and then there's a little baby inside. So it's gastric brooding frog. It's pretty neat. Any questions about frogs or toads before we move on? Besides how cool they are. Okay. Alright, so order Caudata, which is salamanders. Salamanders obviously are a type of amphibian as well. They have a tail their entire life. So their legs are not specialized. They can't jump. Frogs are much better jumpers. I should mention that. Frogs are better at jumping. Toads are good at short hops. So their legs are specialized for jumping and hopping. You have the tree frogs that have the suction cups, and then you have other toads and frogs that have just regular toes. But salamanders, their legs aren't specialized for much of anything. They can jump. They're not even that good at climbing. They just have little stubby kind of legs. They do have the tail their whole life, and they really do need to stay near water. They can't really live far away from water. Most of them are going to live on the forest floor. You might find them under a log or something. They need a lot of moisture though. Sometimes the place that a lot of people find these is if you have a basement and you have like a window well by your basement, they often will fall into those because they're damp and there's a lot of moisture there and they're nice and cool, and then they get stuck down there. So they can live in caves, around water sources in caves. You can find them there a lot. In fact, there are blind ones that live in caves. Cave salamanders are in the entrances of caves also. So these are also in order Caudata. They're going to have internal fertilization. Remember with frogs and toads, they were external fertilization. They had amplexus, they were in the water, and they released the egg and the sperm at the same time, so it's external. With these, it's internal. The males are going to deposit what's called a spermatophore, and the female is going to go over it and pick it up with her cloaca. So it's actually going to be internal fertilization. The larvae have external gills, and so it's those feathery gills. Everybody's familiar with an axolotl. Axolotls have become so popular. So many people are familiar with the axolotls now. That's what the young look like for baby salamanders. Baby salamanders look like axolotls. But axolotl are actually related to tiger salamanders, and they are adults that have never really transitioned onto land, and they stay adults in the water. Most adults are going to lose the gills and transition fully onto land, but an axolotl does not. It's cold over here. kinds of salamanders. We have the Texas blind cave salamander. They're kind of cute. Tiger barred salamander. This was the state amphibian for Kansas. Do you guys know what the state amphibian for Missouri is? I believe it's the bullfrog. Let me see if it's the bullfrog. Missouri state amphibian. It is the bullfrog. I thought so. The barred tiger salamander was the state amphibian for Kansas, bullfrog for us. The axolotl, again, such a common pet now. Lots of people have axolotls. I do think they're cute, but I don't know. I guess I don't see what the real appeal is. Japanese giant salamander is the largest, I want to say the largest amphibian. I want to say this one's the largest amphibian, is the Japanese giant salamander. And then the hellbender is the largest amphibian that we have in the United States. And we do have these in Missouri. I think they're in southern Missouri, is the hellbender. You can see on their hand how big it actually is. It's pretty big. And again, any of these pictures that are starred, that are in Google Classroom, are fair game for the test. Alright, so then we have order Gymnophiona. These are your Sicilians. They're in tropical areas only, so you're not going to find those around here. They burrow underground and eat invertebrates. And they're worm-like with tiny eyes and are nearly blind. Fertilization is internal, and the larva stage can be internal or external. So they're going to have internal or external depending on the particular species. And they're so weird looking. I've never seen one in real life. I have never seen one at a zoo or something. Interesting thing about them, the Sicilian young develop in the mother, and they scrape the inner lining of her reproductive tract with tiny teeth to eat. They eat their mother from the inside. It's very cute. Not really, it's really gross. This is what a Sicilian looks like. Isn't he kind of weird? It looks like a worm. But it's got, like, this is its tiny eyeball. This is its little nose. And it's got a mouth. Can't imagine the first person that found it and was like, what in the world is this thing? And how did they figure out it was an amphibian? I mean, is it a snake? Is it a worm? What? And then they figured out it was an amphibian. So, yeah, that's a Sicilian. It's got a little tiny eye right there. And then that's its nose. And then it's its mouth. And no legs. It's like a little long worm thingy. So yeah, that's an amphibian. And then we're gonna go ahead and stop here and pick up with the rest tomorrow. So we'll do the rest tomorrow. I did want to go ahead and give you, oh, I don't think I stapled it, because I printed off all kinds of fun stuff. Once I get it stapled and find it in this package of fun, I'll give it to you. But it is the frog dissection book.